As you go underwater, you start to pile more water above you, and it's that weight pushing down on you that increases the pressure.
Science has a strict set of laws. One of the biggest ones is about pressure. We used to believe that at 26,000 feet deep, the ocean turns into a biological crushing machine. The weight of the water is so intense that it should turn bones to dust and scramble cells like eggs. But in March 2025, a team deep in the Mariana Trench found a creature that broke the law.
These guys can grow to maybe 36 centimeters in length. The one we caught was over 20 centimeters.
It wasn't just surviving, it was thriving. It has a skeleton that defies physics and a secret history that might date back to the beginning of time. Into the abyss. The ocean is excellent at keeping secrets. It is a vast, cold, and dark blanket that covers 70% of our planet, yet we treat it like a swimming pool. We think we know what is down there. We think we have it all figured out. But the truth is, we are just skimming the surface. The theory was simple. As you go deeper, the pressure increases. For every 33 feet you go down, you add 1 atmosphere of pressure. By the time you get to 26,000 feet, which is deeper than Mount Everest is tall, the pressure is overwhelming. It is about 8 tons per square inch. To put that into perspective, imagine having a large school bus balanced on your thumb. That is the kind of force we are talking about. Scientists believe that at this specific depth, the chemistry of life simply breaks down. Proteins, which are the building blocks of your body, are complex, folded shapes. Under that kind of pressure, they should unravel. Membranes should collapse. Basically, a fish should just turn into soup. But in March 2025, a research ship called the Falkor 2 decided to test that limit. The team, led by deep-sea veterans Jeff Drazen and Patty Fryer, wasn't just going for a joyride. They were on a mission to map the slopes of death in the Mariana Trench. This is the deepest scar on the Earth's crust, a crescent-shaped canyon in the Pacific Ocean that plunges down to 36,000 feet. They deployed a deep-sea lander, a heavy titanium-reinforced robot loaded with cameras and bait traps. It takes hours just to fall to the bottom. Imagine sitting in a control room watching a screen that shows nothing but black water for 4 straight hours. It is eerie. It is quiet. At 20,000 feet, they saw the usual deep-sea cast: rat-tail fish, strange shrimp, terrifying jellies. At 24,000 feet, things started to get empty. The death zone was approaching, but the lander kept sinking. It finally settled on a flat shelf at 27,349 feet. That is 8,336 meters. This is a depth where water density is so high it feels almost like syrup. And then, out of the eternal darkness, it appeared. A small, tadpole-like creature glided into the frame. It was pale, almost transparent, with wing-like pectoral fins stretching out from its sides. It didn't look crushed. It didn't look like it was struggling against the weight of the ocean. It looked relaxed. This was the Pseudoliparis-swirei profundus, a new, deeper variation of the Mariana snailfish. The scientists on the boat were stunned. They were looking at a ghost. This fish was 76 meters deeper than the previous record holder. That might not sound like a lot to us up here, but at those depths, every single meter adds a crushing amount of extra weight. This fish was swimming in a zone where the pressure exceeds 14,000 pounds per square inch. It was existing in a place that textbooks said was impossible for a vertebrate. So, here is the deal. According to everything we know about physics and biology, this fish should be dead. Its bones should be dust. Its muscles should be incapable of firing. But it was hunting. It was snapping at tiny crustaceans. It was alive. The team managed to capture a specimen and bring it up to the surface in a pressurized chamber. This is where things got really weird. Usually when you bring deep-sea creatures up, they melt a bit because they need the pressure to hold them together. But when they got this snailfish into the lab and started analyzing its structure with high-tech scanners, they found something that made absolutely no sense. They looked at the bones. In most animals, if you squeeze a bone hard enough from all sides, it snaps or crumbles. It is basic physics. But this fish had evolved a trait that engineers have been trying to replicate for decades. It is a trait that effectively breaks the rules of material science. The discovery was not just about a fish swimming a little deeper than we thought, it was about how it was doing it. The secret lay hidden inside its skeleton, in a structural anomaly that should not exist in nature. It was an adaptation so radical that it forces us to question if we even understand how life works. This fish didn't just survive the pressure, its bones actually changed shape in a way that defied logic, and the reason why might scare you. The hidden superpower. Okay, let's get into the nitty-gritty, but I promise to keep it simple because this is where it gets mind-blowing. In the world of material science, almost everything behaves in a predictable way. Think about a piece of rubber, a dough ball, or even your own bones. If you squeeze it from the top and bottom, what happens? It bulges out at the sides. Right? You squash a marshmallow, it gets fat in the middle. This is called a positive Poisson's ratio. It is how nature works. It is how physics works. But this snailfish, it decided to ignore that rule. When the scientists analyzed the skull and the spine of this creature using electron microscopes, they found that the bones contained a specific crystal structure, hydroxyapatite crystals arranged in a crazy, complex, interlocking pattern. And get this, these bones exhibit what is called a negative Poisson's ratio. That means when the crushing weight of the ocean squeezes down on the fish, its bones do not bulge out. They actually get denser. They contract inward to support the structure, or in some directions they expand to lock together more tightly. This is called auxetic behavior. In the human world, we use synthetic materials like this for blast-proof curtains, high-tech running shoes, and body armor. We have to build it in a lab using complex nanotechnology. But this fish, it grew it. It evolved bulletproof vests for bones over millions of years. Imagine if you had a car that, when it crashed into a wall, actually became stronger at the point of impact instead of crumpling. That is what this fish is doing with its skeleton. But wait, it gets crazier. The team noticed something else about the skeleton. It was flexible, almost like cartilage, but it had these hard mineral patches. Dr. Alan Jameson, one of the lead evolutionary biologists, called it a middle finger to thermodynamics. Why? Because of something called piezoelectricity. Now, you might have heard of this. It is the ability of certain materials to generate an electric charge when you squeeze them. Quartz watches work like this. You put mechanical pressure on the crystal and it creates a spark of energy to keep time. The bones of this snailfish were showing signs of piezoelectric adaptations. The theory is wild. The scientists believe that the immense pressure of the trench is constantly squeezing these specific bone crystals. This squeezing might be generating a tiny, low-level electric field around the fish's skeleton. So, what does that do? Well, the leading theory is that this electric charge helps stabilize the fish's cell membranes. Remember how I said pressure usually crushes cells and stops fluids from moving? This electric field might be acting like a force field, organizing the water molecules inside the fish and preventing its body from locking up. It is literally using the weight of the ocean to power its own survival, and that explains why it looks so calm in the video. It wasn't fighting the ocean, it was using it. This discovery completely changes how we look at evolution. It suggests that life doesn't just adapt to avoid stress, it can adapt to use extreme stress as a fuel source. But here's where we get into the wild theories. If this fish can generate electricity from pressure and has bones that defy physics, could it be more than just a fish? Some fringe theorists watching this discovery are asking a disturbing question. Is this natural evolution, or is it something else? The genetic code of this snailfish is packed with ancient DNA, stuff that looks like it hasn't changed in hundreds of millions of years. Could the Mariana Trench be a preservation tank? A place where life from a different era, or perhaps a different origin entirely, has been locked away? Think about it. We know that billions of years ago, Earth was hit by massive asteroids. The surface was molten lava. The only safe place would have been the deep ocean. Maybe these impossible traits aren't new adaptations. Maybe they are the original adaptations. Maybe life started down here in the dark, under high pressure, and we, the surface dwellers, are the weird ones who lost our superpowers. And if that is true, what else is down there that never left? The fish was the star, but the monsters it was living with were straight out of a horror movie, and they might be eating the wreckage of a lost history. Giants of the deep. So, the snailfish is the king of the castle, gliding around with its electric bones. But what does a king eat in a place with no sunlight, no plants, and no warmth? The Mariana Trench is basically a giant funnel. Everything that dies in the upper ocean eventually sinks. Dead whales, dead sharks, trash, old ships, it all rains down into the trench. Scientists call this marine snow. But here's the catch. By the time that snow reaches 27,000 feet, most of the good stuff has been eaten by other fish on the way down. The food that lands at the bottom is scarce. It is scraps. So the creatures at the bottom have to be aggressive, they have to be weird, and they have to be efficient. The expedition cameras picked up something swarming the bait traps. At first it looked like static on the screen. Then they realized it was thousands of bugs. These are called amphipods. If you go to the beach and kick over some seaweed, you might see tiny ones hopping around the size of a grain of rice. But down here, the rules of size are broken. We are talking about the Hirondellea-gigas. These things are massive. Some are as big as your hand, and they swarm the bait in densities of 1,200 per square meter. It looked like a writhing carpet of legs and pale armor. The craziest part is their shell. It is made of aluminum. Yeah, you heard that right. A few years ago, scientists discovered that these deep-sea bugs actually use aluminum from the seafloor clay to build their exoskeletons. Aluminum is usually rare in biological things because it can be toxic. But these giants have figured out how to extract it from the mud to build a suit of armor that stops them from dissolving under the pressure. So, picture this. You have a fish with electric bones swimming next to giant bugs wearing aluminum armor. It sounds like science fiction. But then the rover moved to a different spot, a place where an old whale bone had fallen years ago. And there they saw the zombie worms. These are called Osedax worms. They don't have mouths. They don't have stomachs. They latch onto bones and secrete acid to melt the calcium, then absorb the nutrients directly through their skin. They look like shag carpet made of blood-red feathers, waving in the dark current. The expedition also found something totally unexpected in the rocks. They found evidence of serpentinization. This is a big word, but it is simple. It is a chemical reaction between seawater and the mantle rocks of the Earth. The Mariana Trench is a subduction zone. It is where one tectonic plate is shoving underneath another. This grinds the rocks and releases heat and hydrogen gas. Basically, the seafloor itself is leaking fuel, and where there is fuel, there is life. The team found massive mats of microbes, bacteria, and archaea that were eating this hydrogen. They were fixing carbon, creating food out of solid rock and poisonous gas. This is huge because it creates a food source that doesn't rely on the sun. The snailfish eats the amphipods eat the bacteria, and the bacteria eat the rocks. It is a completely closed loop hidden in the dark. This changes the slopes of death into an oasis. It is not a wasteland, it is a thriving metropolis. And the Pseudoliparis-swirei is the apex predator of this alien world. But let's get weird for a second. If these creatures are eating aluminum and hydrogen, and if they are thriving in a place that connects directly to the Earth's mantle, could there be a connection to the hollow Earth theory? Now hold on. I'm not saying there are dinosaurs running around inside the planet, but scientifically speaking, we know there are massive aquifers, oceans of water trapped deep inside the Earth's crust, miles below the trench floor. Could the Mariana Trench be a doorway? Some theorists wonder if these impossible creatures aren't actually from the trench. Maybe they are leaking out from somewhere deeper. Maybe the snailfish is just a tourist from an even deeper, darker biosphere that exists inside the crust of the planet. It sounds crazy, but when you see a worm that eats bones and a bug that wears metal, you start to realize that normal is just a setting on the washing machine. Nature doesn't care about our rules. And if life can exist here, fueled by rocks and pressure, using electric bones and aluminum shells, then why do we think Earth is the only place with life? If nature can build this here, it might have already built it on a moon 400 million miles away. The NASA link. Let's zoom out for a second. Why does NASA care so much about a fish in the Pacific Ocean? Why were there space scientists analyzing the data from this expedition? Well, take a look at Europa. That is one of Jupiter's moons. It is covered in a thick shell of ice, but underneath that ice, scientists are 99% sure there is a massive saltwater ocean. There is also Enceladus, a moon of Saturn, which shoots geysers of water into space. For years, skeptics said, sure, there is water on those moons, but it's dark, the pressure is insane, and there is no sun. Nothing could live there, it is just cold, dead water. Sound familiar? That is exactly what they said about the Mariana Trench. The Mariana Trench is the closest thing we have to Europa right here on Earth. The conditions are almost identical. High pressure, cold temperatures, total darkness, and likely heat coming from the rocky bottom. The discovery of the snailfish's impossible trait, that auxetic piezoelectric bone structure, is a game changer for exobiology. It proves that biology has a toolkit to handle these conditions. If a fish can evolve a skeleton that gets stronger under pressure on Earth, there is zero reason why an alien fish couldn't do the exact same thing on Europa. In fact, Dr. Jameson said something that gave me chills. He said, "We hypothesized impossibility. Nature laughed." This discovery also rewrites the story of how life started on Earth. We usually think life began in warm, shallow ponds, the primordial soup. But some scientists now think the surface of early Earth was too violent. It was being bombarded by asteroids and radiation. It was hell. They think life might have actually started here, in the deep, in the pressure cooker. The genetic analysis of the snailfish showed it had ancient genes, pressure-resistant codes that might be leftovers from billions of years ago. This suggests that the deep ocean isn't just a place where life ended up, it might be where life began. We might all be descendants of creatures that learned to survive the dark first. Now let's push this theory to the edge. If life started in the deep, and if deep oceans are common in the universe, which we think they are, Pluto might even have one, then maybe the universe is full of life. But maybe we are looking in the wrong place. We are looking for radio signals. We are looking for cities on the surface of planets. But what if the smartest, most advanced life in the universe stays in the deep? Think about it. The surface of a planet is dangerous. Asteroids, radiation, weather, wars. The deep ocean is stable. It hasn't changed in millions of years. Maybe the aliens we are looking for are swimming in the dark oceans of icy moons using bioluminescence to communicate, shielded by miles of ice. And maybe, just maybe, the things in the Mariana Trench are distant cousins of things swimming on Jupiter's moon right now. There is a wild theory called panspermia. It suggests that life hops from planet to planet on meteors. If a meteor hits Earth, blasts a rock into space, and that rock carries some of those deep-sea microbes, could they survive the vacuum and land on Europa? The snailfish proves that life is tougher than we ever imagined. It suggests that once life starts, it is almost impossible to extinguish. But just as we are unlocking these secrets, we are threatening to destroy them. We finally found the keys to the universe, and we are about to bury them. We are standing on the edge of a great discovery, but we might accidentally trigger a catastrophe before we understand what we have found. Profit over science. While the research ship Falkor was scanning for new species, other ships in the Pacific were scanning for something else entirely. They aren't looking for life. They are looking for money. Specifically, they are looking for nodules. If you go to the bottom of the deep ocean, especially in a place called the Clarion-Clipperton Zone, which is right near the trench, the floor isn't just mud. It is covered in these potato-sized rocks. They look like dirty lumps of coal. They look like nothing. But if you crack them open, they are a gold mine. These rocks are called polymetallic nodules. They took millions of years to form. They grow by absorbing metal directly from the seawater, layer by layer, over eons. Inside these ugly little rocks, you find pure nickel, cobalt, and copper. Why does that matter? Because these are the exact ingredients we need to build the future. We need them for electric car batteries. We need them for wind turbines. We need them for the smartphone you are holding in your hand right now. The demand for these metals is exploding. We are running out of them on land. But down there, down in the dark, there are trillions of dollars just sitting on the floor waiting to be picked up, and the mining companies are desperate to get down there. They don't want to send divers. You can't send divers to the abyss. They want to send machines. They have designed massive robotic harvesters. Picture a combine harvester from a farm, but the size of a two-story house made of reinforced steel driving on tank treads across the bottom of the ocean. These are basically giant underwater bulldozers. They are designed to scrape the top layer of the ocean floor, suck up the rocks, and spit out the mud behind them. The International Seabed Authority is currently debating permits that could open up over 1 million square kilometers of the abyss to this kind of mining. If they sign those papers, they won't just be picking up rocks. They will be triggering an underwater apocalypse. Here is the problem. In the deep sea, the water is super still. There are no waves, there are no strong currents to wash things away. If you kick up a cloud of dust down there, it doesn't just drift away like smoke. It hangs there. Scientists call these sediment plumes. If these machines start driving around, they will create massive clouds of sharp, abrasive dust that could hang in the water for months, maybe even years. Now remember our friend, the snailfish? The one with the translucent skin and the delicate high-tech bones? It doesn't have lungs. It breathes through gills. It filters the water to survive. If you fill that crystal clear water with thick, heavy dust, you clog those gills instantly. You essentially suffocate everything in the area. It would be like a sandstorm that never ends. But the physical damage is just the tip of the iceberg. We literally just discovered that the deep ocean is a major carbon sink. The bacteria, the worms, and the snailfish help trap carbon dioxide. They are fighting climate change for us silently in the dark, and we are about to drive a bulldozer through their living room. But let's go deeper. Let's talk about the things the mining companies don't put in their brochures. Here are the wild theories that have some scientists absolutely terrified. For decades, we thought oxygen only came from plants and sunlight. Photosynthesis. But recently, scientists found something impossible happening around these nodules. The nodules carry an electric charge. They act like natural batteries. When they are sitting on the seafloor, the electric charge is strong enough to actually split water molecules apart. They separate the hydrogen from the oxygen. They are creating oxygen in the pitch black without any sun. They call it dark oxygen. The theory is that the animals down there, the ancient life forms, might depend on this battery-powered air to survive. If we harvest these rocks to make Tesla batteries, we might be unplugging the life support system for the entire deep ocean. We turn off the oxygen. Everything dies. We know that the deep ocean floor is a time capsule. It contains layers of mud that haven't been touched for millions of years. We know that ancient bacteria and viruses can survive in suspended animation. They are trapped in the mud. They are trapped in the methane ice. If we start dredging up the bottom of the world, could we release something we aren't ready for? Some biologists worry about an ancient pathogen, a Pandora's box from the deep. A virus that existed before humans, before dinosaurs, something that our immune systems have never seen. If these plumes of mud rise to the surface and those ancient microbes get into the food chain, we have no idea what happens next. Sound travels differently underwater. It travels faster and further than in air. Right now, the abyss is the quietest place on Earth. It is a sanctuary of silence. The animals down there use tiny vibrations to hunt and communicate. If we drop hundreds of industrial mining machines down there, grinding rocks and roaring engines 24/7, we will turn that silence into a heavy metal concert. The theory is that this sonic pollution could shatter the navigation systems of creatures we haven't even seen yet. It could drive whales insane. It could disrupt the migration of massive squids. Some theorists even believe that the deep ocean floor acts as a stabilizing force for the Earth's crust. We know there are fault lines down there. We know there are pockets of pressurized gas. If we start scraping and drilling, are we poking a sleeping bear? Are we risking underwater landslides that could trigger tsunamis? Are we messing with the chemistry of the entire planet? The discovery of the snailfish, Pseudoliparis-swirei, is a warning. It is telling us that the ocean is not empty. It is complex, it is fragile, and it is full of solutions to problems we haven't even encountered yet. We used to think the bottom of the world was a dead end. Now we know it is a vault of biological miracles. There could be the cure for cancer in the slime of a hagfish. There could be the secret to anti-aging in the DNA of a tube worm. The question is, are we going to protect this library of life, Or are we going to burn it down just to get the copper wiring out of the walls? It has survived everything the universe has thrown at it. It would be a tragedy if the one thing it couldn't survive was us. So what do you think? If life can thrive at 27,000 feet with electric bones, what else is hiding down there? Do you think the government is hiding even bigger discoveries from the deep? Let me know your craziest theories in the comments below. And if you want to keep exploring the unknown, make sure to like this video and subscribe. Thanks for watching.